Today we are starting a completely new chapter, so everything in this section is going to be very different to what we just tested on. So today we're going to be talking about radicals and the exponents that go with it. So you're going to hear two different new terminology, which would be exponents and its equivalent radical form. So the first rule at the top of your page says the rational exponent, and the rule essentially says that if I have a to the 1 over n power, it's the same thing as taking the nth root of a. The n could be anything such as the square root, or I could be taking the cube root, or the fourth root, or so on. So n could be any value, it could be any number. So just to do a few examples, when you look at the first problem, the square root of 4, it's implied that there is a 2 here when it's a square root. So when I look at this problem, if I'm putting it in its equivalent exponential form, we would say that a is equal to 2. So for the second example, they would like to know what b is, and notice I'm taking the cube root of the problem, so that means b is equal to 3. For the last one, notice I'm taking the fourth root, so this is going to be the same thing as saying 81 raised to the 1 over 4 power. So that means c is equal to 4. So now we're going to practice going the other way. So now we're in what we call radical form. So whenever I have a root, we are in radical form. So if I have the fifth root, this is the same thing as saying x to the 1/5 power. The second one, I'm taking the cube root, so that means this is the same thing as saying a to the 1/3 power. And lastly, finishing up in this section, I'm taking the square root, so it's implied to have a 2 here. Just like we don't write, when something's raised to the first power, we don't write the 1 there. When I'm taking the square root, we don't necessarily write the 2, it's implied. So that means this is m to the 1/2 power. So this is true with variables. This is also true with numerical values. So here I have 5 to the 1/4 power. So that's the same thing as saying the fourth root of 5. And 20 to the 1/2 power means it's the square root of 20. You could write the 2 there if you wanted. You don't have to if you don't. So now we're going to talk about what happens when that top number is not 1. So if you notice that whole section, the top number is 1 for every single problem. So here we have a to the m over n. What I want you to notice is that the bottom number from the fraction becomes the root power. So I'm taking the nth root of a to the m. Another version of the formula is that I could take the nth root with the m on the outside. Doesn't really matter where you put that exponent, it kind of is the same forms. So here, if I have the fifth root of x to the 4th, that's the same thing as saying x to the 4/5 power. So again, notice the key thing to remember is that the bottom number of the root goes to the bottom part of the fraction. So the next one we have is the cube root of a squared, so this is a to the 2/3. For the third example, again, it's implied to be a 2 there, so this is m to the 5/2. Notice the 5 here, this exponent was on the outside of the root, whereas all the other examples it was inside the root, but this rule still applies. So now, kind of flip-flopping, we're in exponential form, and I want you to put it in radical form. So d to the 3 over 4th power is the same thing as saying the fourth root of d cubed. And lastly, y to the 7/2 power is the square root of y to the 7th. So this is one skill we're going to practice, is going back and forth between exponential and radical form. So the last thing I want to go over is on the next page, you're going to see several rules. So you're going to see a total of 1, 2, 3, 4, 5, 6 rules. We're going to focus on rule, if you number straight down from the top 1 through 6, we're going to focus on rules 1, 2, and 5 for the remainder of the video. So rule number 1, the property on your table says a to the m times a to the n is the same thing as saying a to the m plus n. So notice when I have the same base, I keep the base and we add the exponents. So, and this is a typo, this should say times there. So if I'm multiplying and I have a to the 1/3 times a to the 2/3, we keep the base and we add our exponents. So this is the same thing as saying 8 raised to the 1/3 plus 2/3. And when I'm adding fractions, I need to have common denominators. I have my common denominator of 3, so that means I'm going to add the tops. So this is 8 to the 3/3, because 1 plus 2 is 3. And this fraction of a 3/3 can be simplified to the first power. So my final answer would just be 8. So again, when I'm multiplying with the same base, I add the exponents. So that's the first property. The second property we're going to focus on is when I'm raising a power to a power. So I have a to the m raised to the nth power. So a little different than the first property. The first property, there was 2 bases. Here there's only 1 base. And now I am multiplying my exponents instead of adding them. So here my base is 5, and I'm raising it to the 1/2 power raised to the 4th power. So if I follow this property or the rule here, I keep the 5 and I multiply my exponent of 1/2 times the 4. And we can think of this as like a 4/1. And when I multiply fractions, you multiply straight through top and straight through bottom. So this means it's 5 raised to the 4/2 power. And 4/2 can be reduced or simplified to being 5 to the 2nd power. So my final answer here is 25. Again, we multiplied our exponents and simplified. So last example I want you to focus on is the 5th rule. So it's the second from the bottom. And on your table you'll see the rule that says a to the m divided by a to the n. And when I do that, when I'm dividing my bases, it's the same thing as saying a to the m minus n. So notice how I am subtracting my exponents. So for the example here, I have 7 to the 3/2 power divided by 7 to the 1/2 power. So I keep my base of 7, and now I'm going to subtract my exponents of 3/2 minus 1/2. Just like in adding, I need to have common denominators. In subtracting, I need to have common denominators. And in this problem, I'm already set up with those common denominators. So I keep my base of 7. And when I go to subtract my fraction, 3/1 is a 2, and I keep the bottom of a 2. And 2 divided by 2 is 1, so that means it's 7 to the 1st power. So my final answer is 7. So tomorrow we're going to do practice on going back and forth between exponential and radical form and focus on practicing these 3 rules. Okay, that's all for today.